Hi everyone, welcome back from spring break. We are starting our second to last chapter, and this chapter is called Logarithmic Functions. So what I'm working out of today is not in the big pink packet. This is probably a section that should have been put in there but has not been put in there. So we're going to call this pre 6.1, and what we're going to look at is this new type of function called logarithmic functions. And we're going to see how they can compare to our last chapter of exponential functions. And the idea of this section is what you're going to realize is that the exponential functions, for instance, when we add 2 to the x power, it has an opposite, it has an inverse, and that is the form of a logarithmic function. So the first thing to point out is we're going to start using these buttons on our calculator over here. One says log, and the other says ln. This is not in, it's not in, it's ln, okay? And these will be our main buttons for this chapter. So if you don't have these notes, you can just put them on a piece of paper. There really isn't that much to put. The main thing I want you to do is, if you are taking these notes on a piece of paper, is just to write down the examples that we do. All right, so you don't need to write all of this stuff down. So starting with logarithmic functions. So a logarithm, it's just the inverse, which means that's the opposite of an exponential function. And the logarithm of y with base b, that's how you say this. So log of y with base b, okay? You could also say log with base b of y. But b is known as the base of the log. It's this little sub number. And y, whatever's behind that, that's called the argument. And so what you're going to see is that if you do have this log equation, here is its equal counterpart as an exponential equation. All right? There are a couple rules to this, so just take a notice that the base of the log is the base of the exponent. The answer of the log is actually the exponent of the exponential, and then the argument of the log is the answer in the exponential function, which you aren't expected to memorize that. There's going to be a little trick. But the main thing is, in either situation, whether it's a log or an exponential function, that this base has to be bigger than 1, and that shows growth, if you remember from our last chapter. Or if it's in between 0 and 1, then that is exponential decay. So in the last chapter, we actually didn't use b, we used g for growth factor. So what you're multiplying by. So if what you're multiplying by is bigger than 1, then you're going to have that growth shape, is what we talked about last chapter. And if that b, or growth factor, sorry, is in between 0 and 1, like a half, and that means you're multiplying by a half, then your numbers would be getting smaller, and that would represent decay. So in this case, we're going to go back to b being the base. Again, it has to be bigger than 1, or in between 0 and 1, and then y, this has to be a positive number, and that's going to be very important when we get to logs. Whatever the argument is going to be has to be a positive number. And what happened in exponential functions is, this y that we're referring to, we never got a negative number. It was always, it can be 2, 3, 4, it can be fractions, but it was never a negative number. So anyway, that's a lot of talk there. Let's go into the examples. So how does something like this look like an exponential equation? So what we're going to do is we always start with the base. This is going to be a little trick that you're going to do, and you're going to always you're going to be going around this equal sign, but you're going to say 2, whoops, if I can get this color to show up, 2 to the 4th power is 16. And what we're going to do is make a very cursivy loopy e for exponent. So 2, show you again, to the 4th power is 16. And that is true because this just means 2 times 2 times 2 times 2. And if you multiply these 2's, you get 4. If you multiply these 2's, you get 4. Then that 4 times that 4 is your 16. So what we're going to do when I ask you to make an exponential equation from a log, you're going to make an e out of it. Now, if I give you the exponential version and I want you to make a log, well, then we're going to come over here and we're going to make an L. And it always starts with the base. So the first thing is we're going to need the word log written in our problem. That's just the no-brainer there. But what I'm going to do is I'm going to start up here and I'm going to hit 5. And then I'm going to go around the equal sign to 25. That's the next number I write. And notice that the 5 is a little sub number, and log and 25 are all the same size, same level. and then I'm going to go back around the equal sign, hit that 2, and then I'm going to come back up so you can see my capital L that we just made. So there's one really big thing to realize. The base of the log is the base of the exponent. The base of the exponent is the base of the log. And then it's the other two parts that go into different places. So again, just back to the vocab, this is the base and this is the argument. All right? So this is not a number that would come naturally to us. This one is 5 to the second power is 25. So what we're going to have to do is just to look at logs as exponential functions. So we're going to go down here and we're going to practice a few, and I do want you to write them down as we go through them. So when I see a log, we're going to do all the log problems and turn them all into exponents. So I would never know that log base 4 of 1 is worth 0. So if you rewrite it as an exponent, hopefully you see why. So you start with the base. 4 to the 0 power is 1. And that's true. Anything to a 0 power is 1. So let's go to this one. 12 to the first power is 12. And that's true. Anything to the first power is just itself. So let's keep looking at the log ones. 3 to the second power is 9. And remember, you can pause this video to write the problems down. Let's go to this one next. 2 to the fourth power is 16, which is one that we already did. Let's finish the easier ones. I'm going to jump down to this one. 3 to the fifth power is 253, or 43, sorry. So if I multiplied 3 5 times, 3 times 3 times 3 times 3 times 3, you would get 243. So let's take a look at the two that are just a little different. So 6 to the negative third power is this fraction number. And that is true. So this is just a reminder that negative exponents don't make negative numbers. They make fractions. So what I tell my freshmen is when you see the negative, you move it. So you move this whole thing and you move it into a denominator. And once you move it, you lose the negative part of the exponent. So move it and lose it. And 6 to the third power, 6 times 6 times 6 is that 216. So let's take a look at this one. Let's rewrite it first. So there happens to be another negative exponent. And let's talk about why this works. So first, what I want you to realize is that this is the same as 2/10. And 2/10 can simplify into 1/5. So now what I want you to look at is the problem in this format instead. And when you see a negative exponent, it moves. And then once you move it, you lose the negative exponent. So that's how you can figure out what a log is worth, is if you view it as an exponent. Now, not all logs will be that simple, and there's your calculator that will help you with that. But let's take a look at these and how you write them as a log. So first you have to write the word log, and you start with the base. So, and then you go to the other side of the equal sign, and notice the 4 is little, but everything else is normal size. Then I put my equal sign, come back up, and I hit the 3. So log base 4 of 64, this is the argument, I get 3. Let's just move to the one below it. So I write log base 5. Then you come over here, you hit the 625. Come back up, equals 4. So log base 5 of 625 is worth 4. So let's just try these last two. Log base 6. Come over, 36. Come back over to the other side of the equal sign, equals 2. And then the final one, log with the base of 3, 27 follows it, come back up, equals 3. And not that you have to make these E's and L's, but if you want a little trick, all right? Okay, so that is how you go from a log to an exponent and an exponent to a log. They are equivalent to each other. They just look a little different. So let's talk about some of these over here and see if we can figure out what these logs are worth. And we're going to do the first round without a calculator and the second round without a calculator. So how do I know what log base 6 of 36 is worth? Well, I just need to realize that, what is this worth? So I'll put a little exponent there. That 6 to the what power makes 36? And hopefully you realize that that's 2. Okay, so on this one, put a little x here. 2 to the what power makes 16? And that's 4. And on this one, 3 to the what power makes 81? So how many times would I have to multiply 3 to get 81? That would be 4 times. So let's go to this one. 14 to the what power gets me to 1? Well, anything to a 0 power is worth 1. And then this is the one that we just did. So let's just remind ourselves that this is 2/10, and 2/10 simplified is 1/5. So 5 to the what power is going to make 1/5. Again, negative exponents make fractions, so this would be worth -1. And the last one, what's different about this one is this one doesn't have a little base. And there are times in math where we have invisible numbers, and this is one of our invisible numbers. There is an understood little 10 there when you don't see a base. So what we want to know is 10 to the what power gets me to 100, and that's going to be 2. So there are going to be logs that you can do without a calculator, but there are going to be logs that you need a calculator. And you have to have a graphing calculator, and we have to make sure you have the updated operating system. So if you have any type of 84 calculator, you will have, or we can put on your calculator, an updated operating system. If you do not have an 84 calculator, then you have to use something what's called the change of base formula. So real quick, going up here, how could I do this without a calculator? So again, we're just asking ourselves, 4 to the what power makes 64? So you would just have to start to see how many times would you have to multiply 4 to get to 64, and that would be 3. Now, if you do have a calculator, what you can do is you can press, these are buttons, the math button, okay? So you press this button, and then I want you to scroll up. So from there, you're going to hit that scroll up button. I guess it's more curvy though, isn't it? And then you're going to see here log base, and you want to select option A. So you can scroll to it. Whoops, it's probably the fastest. And then what will happen is everything's going to pop in place. And I can put the little 4 here, arrow over, put the 64 in, just arrow out, and then you're going to get your answer. So math, scroll up, put the numbers in the right spot. Now, if you do not have an 84 calculator, then you have to know the change of base formula. So unfortunately, that's just the way it's going to go. So the change of base formula looks like this. And you just take the log button and you put the argument on top in parentheses, and then you press the log button again and you put the base number on the bottom. So in this case, I would do log. It will start parentheses for you, and you'll have to close them and put the 64 in there, and then divide it by log, start the parentheses, and put 4 in. The other option is you can use the LN button below it and do the exact same thing if you want. So it doesn't really matter which button you push. So for instance, if I'm going to press log, and if you notice it starts the parentheses, 64, close the parentheses, divided by, I press the log button again, and I close my parentheses, and I'm going to get the answer. So either way, you can figure it out, but the math and scrolling up is going to be the best option. So again, for these, I'll show a couple with the math option, and then I'm going to show a little bit more with the change base formula. So we're going to leave these alone for now, and we're going to start here. So most of us can press math, scroll up to A, put the 27 in, arrow over for the 3, and then we're going to see our answer, 0.33333. But if you don't, then you need to do log, it starts parentheses, close the parentheses, and then log and put the base in the bottom. Remember, base in the bottom, and then you'll get the same answer. So for this one, I would do log 42 and then log 3, base in the bottom. And so just showing you again what that looks like, press the log button, 42, close those parentheses, log 3, close those parentheses. Otherwise, you can press math, scroll up, and then just put your little 42 in, and then your 3, and you're going to get the same answer. Whoops. Which one did I do wrong? Oh, I switched them, sorry. I put the wrong number. I wasn't looking, so it's 3 in here and 42 in here. Sorry about that. Then we get the same answer. All right. So either way, you're going to get 3.402. And just for the record, we're always going 3 numbers behind the decimal. So this one, I would do log of the argument, in parentheses, over log of the base. So again, just showing you what that looks like. Okay. And you're going to get this decimal. All right, let's talk about these. So these, any calculator will work. This is the ln button. So any calculator can actually type ln and 0.75, and it will do it for you. And we'll talk about what ln is meaning in just a little bit. So here I'll go 3 decimals and make it negative 0.288. And then here I could type in the ln button with 14, and I'll have 2.639. Now, if it's just a regular log, then you can actually use this log button here, okay? Put in the 12 on any calculator, and we'll have 1.079. Remember, if you don't see a little number there, there is an understood 10. All right, let's talk about some important logs that you should just remember. So first of all, regardless of what the base is, if you're taking the log of 1, you will always get 0 as your answer. And the reason why is from that exponent rule is that the base, whenever the base is to a 0 power, you always get 1. b to the 0 power is always 1. When your base and your argument are the same, you actually get 1. And the reason why is anything to the first power is itself. Okay? Here, this, again, important logs is just, this is log with a little base of 10. It's just understood. And ln is actually a log with that e number, that about 2.71 number. Okay? So ln is a base. It's this e that we worked with in our last chapter. So just some things to think about as you do this. So what we're going to do is go through here, and you know, I've got some of these on the next page, but this one, I want to talk about this. So one thing that I mentioned on the last page, so these were already on their other page. So when you're taking the log of 1, you always get 0. When your base and your argument are the same, you always get 1. But when you take the log of a negative number, or you try to take the log of 0, you will get an error message. This is not possible. Okay? And the reason why is you can't take something to a power and get a negative number. This is never going to happen. Or 0. This is impossible. If you take b to some power, that will never happen. And a good example to see is if you just, you know, took 2 to the any power, and then if you looked at your table, you're going to see that I will never get a negative number. These numbers will get smaller, right? And that's what this is saying, that these are getting closer and closer to 0. But they're never going to become 0, and they're never going to be a negative. And the reason why is, remember, when we did graph 2 to the x, it would look something like this, and we would have that wall that would never allow the y values to become 0 or to become a negative number. So that's why you can't take the log of 0 or a negative number, because in its exponent form, this would never work. So let's just try a few of these random problems here. So what would happen if you had the function f of x, and I asked you to put 4 in here? So just putting that. So if you don't know what this is, you ask yourself 2 to the what power makes 4, and that's worth 2. Or if we did this one, 2 to the what power makes my fraction of 1/2. Well, a fraction comes from a negative exponent, and that negative exponent would have been a -1. And then, for instance, this one, again, as soon as you're taking the log of 1, your answer is automatically 0. And hopefully that's one you remember. If not, 2 to the what power makes 1, that's a 0 power. All right, so that's it for this section, I think. So I think we'll probably have run out of time, so we'll look at some of the other problems when we see each other in class.